Okay, we will be simplifying expressions, not solving equations, but simplifying expressions. Two different things we'll do here are combining like terms and distributing. So we've got to get some vocabulary down first to get this. We've got algebraic expressions. That's what it's all about here. A mathematical phrase that can contain ordinary numbers, variables like x or y, and operations like add, subtract, multiply, and divide. It's not an equation because there's no equal sign. Get that right. It could be like the left side or the right side of an equation, but not the whole thing. Okay, so in algebraic expressions, there are terms. They're parts of an algebraic expression, one part or another. A sister or a brother. Okay, we've got like terms. So those are the terms that have the same variables raised to the same exponent or the same power. Interesting. Here are some examples. So we've got like, x, 5x, negative 3x. They're all like terms. Or we've got some regular numbers, I'd call them. 6, 0, negative 13. Technically, they would be called constants, but yeah, those are like terms. Or we've got not just regular x's, but x squareds, x to the second powers. That's negative 3x squared, 15x squared, or just x squared. Simplest form. It's not the simplest thing, but it's called the simplest form. This is when an algebraic expression has no like terms and no parentheses. Everything's been simplified. We have either combined the like terms or distributed when there's a parentheses, or maybe even we've done both. Simplified. So first off, let's check this out. Let's identify the terms and like terms in each expression. So here we would rewrite as a sum of terms. Yeah, so like let's see if it's minus 2, we're like adding a negative 2. Instead of minus x, we're adding a negative x. So that helps us to see exactly what the value of those terms are. So we can see with the red and the blue, we're starting to connect which terms are like each other. Bam! The like terms are the 9x and the negative x. They're both x's. In red, we've got the negative 2 and the 7. Just good old regular numbers that we've known about for a long time now. Technically, I would say they are integers, constants, stuff like that. But, just look at the colors there. Boom. X's over here, numbers over there. Let's check out this one. Oh, z's and z squareds kind of look all the same. They're all z's, but again, they need to have the same exponent. So like the z squareds, they can go together. And the regular z's, they can go together. They are like each other. They are like terms. Apples and oranges. So combining like terms, a type of simplifying here. Let's see, 8x minus 6x. Yeah, let's circle or underline those because they're like terms. They're going to go together. We can actually put them together. And we do that to make 2x. Again, we could think like apples. Oh, there's 8 apples, and then you eat 6 of them. That's a lot. Okay, that's a tummy ache is what that is. But we'll call this 2x. Okay, or 2 apples, I guess we were saying. Minus 25. That's still just minus 25. There weren't any regular numbers hanging around to be combined with that. So we're done. It's not an answer like x equals 7 or the answer is 100. The answer here is just a more simplified version of this expression. Next example. So here we've got a little bit more going on. We've got some y's, we've got some regular numbers. Again, let's circle or underline the like terms. Boom. Y's are going to go together. Regular numbers are going to go together. But why don't we take a step to regroup the like terms next to each other So it's a little bit easier to see what's going to happen with all these terms, all four terms. Well, the y's, let's put them together. 2y's plus 4y's, yeah, that's 6y's. 3 plus 5, that's 8. Extra little step here, but it helps in the middle there to rewrite the expression having the like terms right next to each other so we can see better how they'll go together. Ooh, whoa, what is this? We are distributing. All of a sudden, different thing. We're not combining like terms. We see a parentheses that says basically something on the outside times something on the inside, or times some things on the inside. Bam, draw some arrows. The 3 is getting multiplied by both parts. 3 times x and 3 times -6. So you're drawing those arrows from outside to inside. Next up, distribute the number outside to the numbers inside. It's like that 3 needs to be multiplied to both parts in there. So let's write out what's going to get multiplied. Next, we actually multiply it. 3 times x, we don't know what x is, so it's just 3x. 3 times -6, oh, that's a -18.